You're welcome back. This is Mr. Hassan's Maths channel, and here I have a question from one of the old Solomon H. Edexcel collection papers for the P3 exam, and this is actually answering this question for one of my students taking the Cambridge paper, and this is relevant to the P3 paper of Cambridge. So I have it as question number 4 in my end of topic worksheet for my differentiation 1 worksheet from Cambridge. And here we've got this question about the number of bacteria present in a culture at time t hours. It's modeled by the continuous variable n, and the relationship n equals 2000 times e to the power of kt, where k is a constant. Given that when t equals 3, n equals 18,000, find the value of k to 3 significant figures. So that's simply just replacing t with 3 and n with 18,000 and then finding the value of k. So we got to take n and replace it by 18,000, and you got 2000 times e to the power of k, which we have to find, times 3. So k times 3 is going to be 3k. Okay, k times 3 is 3k. That's when t equals 3. Okay, we have to solve this equation, so we can divide both sides by 2000. Okay, if we divide both sides by 2000 first, we have 18,000 over 2000. Okay, they cancel out, and you're left with 9. 9 equals e to the power of 3k. So if I take ln of both sides, I'll end up with the ln of 9 equals 3k. So therefore I can say k is equal to 1/3 of ln 9. Now the question, this would be the exact value of k, but they want the value of k to 3 significant figures. So I'm going to leave this written in this form, so for future use I'll have the exact value. But now I'm going to also write down the value to 3 significant figures. So I'm going to put 1/3 times ln of 9, and then I'll write this. This is going to be 0.7324. 0.732408. So they want it to 3 significant figures, which will be 0.732. 0.732. So there's the value of k that they're looking for in this question. Okay, 732408. Yeah, okay, good. So there's the answer for part A, pretty simple. Now for part B, it says how long it takes for the number of bacteria present to double, giving your answer to the nearest minute. So the number of bacteria present, okay, starts off initially when time equals 0 as 2000 times e to the power of k times 0. So it's going to be just 2000. Okay, that's in the beginning. So how long does it take for the bacteria to double? Okay, we're going to now just replace n with 4000. Okay, we've got to find what the time is when you have 2 times n. Okay, or 2 times this value. So n, you can call this n0. Okay, the time when it's in the beginning. So 2 times the initial amount. Okay, which is going to be 4000. So we got to replace n with 4000. Okay, in this formula. So we're going to have 4000 equals 2000 times e to the power of k times t. Okay, so we know what k is. K is 1/3 of ln 9. That's a constant that we already found in the first part of the question. So the only unknown here is the t, which we have to find. So again, we can divide both sides by 2000. So we have 4000 divided by 2000 equals e to the power of kt. That gives us 2. So we're left with e to the power of kt is equal to 2. We can take the ln of both sides, so k times t equals ln of 2. So that means t is equal to the ln of 2 divided by k, which is the ln of 2 divided by 1/3 ln of 9. So that should give us our answer. So we just take ln 2 and divide it by the last answer. So we're going to have a fraction, ln of 2 over answer. Okay, that will give you the last answer, which was this in my calculator, which gives us 0.94639. 0.94639. Okay, let me just make sure that I copied that right. Okay, now this answer is in hours. See, the t is in hours, so answer is going to be this. This is going to be in hours, and they want the answer, okay, to the nearest minute. Okay, so what we can do is we can multiply this 0.94639. We can multiply it by 60, and that will give you how many minutes that is. So we take our answer and we multiply it by 60, and that gives us 56.783. That's going to be 56.783. Is it 783? Yeah, 56.783. Okay, this is now in minutes. So therefore we can say the time to the nearest minute is 57. 57 minutes to the nearest minute, as they want in the question. Okay, so that's the time in minutes to the nearest minute. Okay, so that's the answer to question number 5, part B. Now the part that's relevant to our topic worksheet, which this is from, which is the end of topic worksheet on differentiation, is this part of the question. It says find the rate at which the number of bacteria is increasing when time equals 3. So whenever you see the word rate, it means the rate of increase or rate of decrease, the rate of increase basically. Then we think of the rate of change of the number of bacteria with respect to time, which means that they're trying to ask us to find the value of dn dt, okay, when t equals 3. That's what they're asking us to find. Okay, so the first step is for us to find dn dt. So dn dt, when you differentiate something like this, okay, it's like the basic function is e to the power of something, right? So when you differentiate e to the power of something, it doesn't change. So 2000 e to the power of kt will stay 2000 e to the power of kt. But then you have to multiply by the differential of what's inside the function. So you have to multiply by that constant k. Because you differentiate e to the power of kt, you get k. If you differentiate k times t, you get k. And that's the part that's inside the function using the chain rule. Alright, so basically we're done here because this is 2000 times e to the power of, now we know k is a third ln 9, we found that already. So, and we know t is 3. So when t is 3, you're going to have 1/3 times ln 9, and you're going to have times 3, okay, and times k, which is a third ln 9. So this is going to give us, I mean, I could stick this in my calculator and get the answer, but I'm just going to work part of it out. 3 times a third cancels out, and you have e to the power of ln 9. Now e to the power of ln 9 is going to be just 9, because you know this is like the inverse function inside the original function. They cancel each other out. So this is going to be 2000 times 9 times a third ln 3. Okay, 2000 times 9 times a third ln 3. So you can say they cancel out with each other. So 6,000 times ln 9. 6,000 times the ln of 9, which should give us our answer. 6,000 times the ln of 9, which gives us 13,183. 13,183.347. Continues on. Okay, that's going to be rounded to, because it doesn't state how to round it, so we'll round to 3SF. So we'll say 13,200 is the answer. That's the rate of increase of bacteria when t equals 3. Okay, so that's number of, that's the how much it the bacteria is increasing by every second. All right, so there's the answer to the question. That's dn dt. This is dn dt when t equals 3. All right, so there we have it. Okay, let me just make sure I didn't make a silly mistake on the way. We can just put this in our calculator as it is from here. Just see 2000 times e to the power of ln 9. We can say, I know that's going to just become 9 anyway, but just to make sure, times a third ln 9. Yeah, it gives us the same thing. Okay, fine. All right, so that wraps up this question. Question number 4 from the end of topic worksheet, and question number, I think, what was it? 5 from the Solomon H paper. All right, so other questions from this particular paper, the Solomon HP3 paper, can be found in the playlist over here. And you'll find other questions from this end of topic worksheet, differentiation 1, in the playlist down here. At the end of the video will be linked there. You can subscribe to my channel by clicking on this link. Okay, and a video here will tell you how to use my channel to find what you're looking for. Thank you for watching and see you soon.